The next topics which we will be covering under chemical bonding is firstly the characteristics of an electrovalent bond, which is also called as an ionic or a polar bond. Nextly, the formation of the electrovalent bond, on what basis these are formed, and lastly the various types of ions which are formed. Let's start with the first topic, which is the characteristics of ionic bonds. As we already studied in the previous session, is that an ionic bond is formed by oppositely charged ions. That means a positive and a negative charge combine with an electrostatic force of attraction, and thus it is formed. So firstly, it is about the composition. So, an ionic bond is made up of positively and negatively charged ions. The next being the melting and boiling point. Now, ionic bonds have high melting and boiling point. The reason for this is that they have a high electrostatic force of attraction between them, and thus a high amount of energy is required in order to break these bonds. B, we mentioned about melting and boiling point. Third being the solubility. Now, ionic bonds are soluble in water, but they are not soluble in organic solvents like benzene or acetone. The fourth one being is the electrical conductivity. Now these are highly electrical, they have high electrical conductivity in their aqueous or molten state, but at the same time in their solid state they do not conduct electricity. This is because the atoms are held together in rigid position and hence they cannot move. On melting them, or when they are bring to their aqueous solution, their crystal structure breaks and the ions are free to move, and thus they conduct electricity. The second topic is the formation of ionic bonds. The first topic in this is firstly they are formed solely because of electrostatic force of attraction. The next is how these are formed. Firstly, it is the ionization potential. Now, ionization potential is defined as the elements which loses its electrons in order to become a cation. The ionization potential should be low in order to form a cation. The next one being is the electron affinity. This is formed by those elements which gains electron to form an anion. The electron affinity should be high for the element which is forming the anion. And lastly, it is the lattice energy. The lattice energy is the amount of energy released when the ions combine to form a crystal. The lattice energy should be high. This is because when both the atoms, being it positive and negative, are combining, the energy released is called as lattice energy. The summation of ionization potential plus electron affinity and lattice energy should be negative. This indicates that energy is released while the atoms are getting formed, combining and forming a molecule. The energy released makes them more stable, and thus, as I explained previously, in Na plus and Cl minus, the energy is released, making it energy liberation, and thus we are getting sodium chloride. The third topic is the different types of ions. Firstly, it is called as ions which are of inert gas configuration. Inert gas configuration means atoms having NS2 or NS2-NP6 configuration of electrons in their outermost shell. For NS2, the examples being, firstly, it is helium. Helium is having an atomic number of 2, making it a stable element. In order to attain the configuration of helium, hydrogen having 1 as atomic number gains 1 more electron and thus becomes negatively charged. Secondly, let's see how to write the electronic configurations based on sp, d and f model. All you have to do is make a triangle in a way S, P, D, and F. So just write 1, 2, 3, 1, 2, 3, 4 and just mention S, P, D and F. 1 is to 4 and 5 F. Now when we write the electronic configuration, we go diagonally downwards. First it will be 1s, followed by it will be 2s, then it is followed by 2p, 3s, 3p, 4s, and then it goes like this. Yes. So this is the pattern when you're writing the electronic configuration. Now let me give you an example. For example, for magnesium having an electronic configuration, having atomic number 12. So when you're writing the electronic configuration, first of all, it is 1s. As 1s appears first, it can contain 2 electrons. So 2. Next is 2s. Again, it can contain 2 electrons. So it's 1s2, 2s2. Now we have 8 electrons left. The third one is 2p. So after 1s, 2s, next comes is 2p. 2p contains 6 electrons. Thus, it's 6 plus 2 plus 2 making it 10. And it is 3s, which again contains 2 electrons. So for magnesium, it is 1s2, 2s2, 2p6 and 3s2. So when I was explaining the different types of inert gas configurations, different types of ions, the first one was the inert gas configuration with NS2 model. For NS2NP6, we have magnesium. I'll just take the example. So when magnesium loses 1 electrons, it becomes Mg plus ion. That means that 1 electron is lost from the s orbital. When it loses the another electron, it becomes Mg2+. Thus, in this case, the 3s electrons are lost and we get the configuration of 1s2, 2s2, 2p6, which is equivalent to neon. Next is exceptional configuration. For example, it is chromium. Chromium having the atomic number of 24, its electronic distribution goes as 1s2, 2s2, 2p6, 3s2, 3p6. So the number of electrons firstly is 6 plus 6, 12, 13, 14, 15, 16, 17, 18. Now the next one is 4s and the other one is 3d. Now what happens in chromium is, the next ideally what should happen, S should contain 2 electrons, but in this case S contains 1 electron and 5 electrons are present in 3d orbital. The reason for this is the 3d orbital makes it more electronically stable instead of making it as 4s2 and 3d4. Thus, this is a stable configuration as compared to this one. Similarly, we can take example of copper having 29 as atomic number. We will write the electronic configuration in the same way. 3s2, 3p6. Now in this case, again 4s consists of 1 electron, but the d orbital consists of 10 electrons, making it fully filled. Thus this half filled and fully filled orbitals make them a stable configuration.